Hey everybody, we are going to dive into example 7 over here where we're choosing between investments. We're talking about banking problems, percent growth, and things like that. So in a nutshell, very quickly want to discuss these two formulas. The first formula here, A equals P times the quantity 1 plus R over N raised to the N T, is used for N compoundings per year. So what does that mean? So if you compound annually or once a year, everywhere that you have N, right, you're going to fill in a 1 everywhere you have N. If you compound semi-annually, that means twice a year, you plug in a 2. Quarterly, that means 4 times a year, N is 4, then you plug in 4. Now that doesn't mean that if your interest rate was 100%, right? You get 100% return on your investment and you compound annually. That would mean that you get if you start off with $1 as your initial value, right over here, P is your primary investment or principal amount. A is the amount at the end. R is your rate as a decimal. N is the number of times you compound in a year, and T is time in years, okay? Now, if you start off with $1 in the bank, right? And your interest rate is 100%. That means as a decimal, R is 1. Move the decimal twice, right? And you compound your interest once a year. That means N is 1. And you leave your money in the bank for 1 year. Well, what does that mean? Well, that becomes a 2. Raised to the first is 2 times 1, 2. You get $2 at the end, which should make sense. You get 100% return on your investment. You have $2 at the end of 1 year. When you compound the interest more than once a year, you're not getting 100% each time. If you're going to compound semi-annually, what that means is your rate of 100% gets divided by 2. So that means you get 50% interest 6 months in. You get the other 50% interest another 6 months later. But now that second 50% interest, 50% return on your investment is getting tacked on to a larger number, so you just get a smidge more. So what does that mean? For example, start off with $1, right? You're getting 50% return on your investment twice throughout the year, right? So initially after 6 months, then you have $1.50 because you saw 50% return. Now 6 months later, you're going to see 50% of that. What is that going to be? So that was plus 50 cents, right? Now you're going to see plus 75 cents because it's half of $1.50. Now you're going to have $2.25. So the other account, we got $1. This one we get $2.25. You don't get $4. It's not like it doubled twice in the year. That's not what happens, okay? So let that marinate, let that sink in. And that's really what happens. But before we move on, and quick chat about continuously compounding interest. I have another video where I go into a little bit more about Leonard Euler. It's pretty old, but it's still there. It still makes sense, still valuable, right? So he wanted to know what happens if we just never stop compounding this interest. Maybe you do it once a year, twice a year. Well, now let's do it 4 times a year. Let's do it every month. That's 12 times a year. What happens? Will that money, that $1, turn into $1 million? Let's find out. So I have a little spreadsheet set up and ready for us to go. So what is going on in this spreadsheet? This is a Google Sheet, and in here I have a formula typed into the box right here. I could kind of show you. So the formula you should be able to see probably better over on the oops, I didn't mean to do that. Backspace that. So B2 is going to be the 1 under the P for principal. Dollar signs to sort of lock it in place. Ignore those for now. We could have a conversation about how to lock a row or whatever another time. I don't have time right now. Times the quantity 1 plus C2, which is your R, over N. So that's going to be, these are all describing the box. So B5 and then raised to the NT, which is B5 times D2. Now what happens is as I go down, my formula changes from B5 to B6. then the one below that, the B6, the B7, but all the other ones with the dollar signs are sort of just locked in. The only one moving is my B, and that's this lime green column over here. So what we're going to do is we're going to pretend like we're Leonard Euler, okay? And we're going to say, all right, what happens if I compound this interest one time a year? So I put $1 in the bank. I did do the decimal out further than 2 decimal places so we could really see. So if I only put $1, I leave that in for a year, then I have $1. Sorry, my keyboard is ginormous right now, but I'll get rid of it in a second. What if I compound that interest instead? So if you see on the right, I have some words to describe. On the right, semi-annually. So that means that I'm going to fill in twice a year. So that's going to be 2 times a year. Well, now I have $2.25. Quarterly. So how many times a year would that be? That's going to be 4 times per year. Next will be monthly. So that is going to be 12 times a year. So if you're watching, what's happening to the money? Are we approaching infinity? Maybe you think so. Let's keep going. Weekly. How many weeks are in a year? I hope we all know. 52. So I went from once a month to 4 times a month, more than 4 times a month, and only going up about 8 cents. Daily. So let's use 365. Next is every hour. Hourly. If you don't know how many hours there are in a year, I'm going to do, did not need to write that. I'm going to write equals. So this is me. I'm going to write a formula. The box above it. And then I'm going to do an operation of times. So if it's hourly, I'm going to do times 24. And it just does the math for me. There we go. So if I went from daily to every hour, I mean, I moved like a penny because it's $2.71, $2.72. All right, what about every minute? So let's do what we just did. Equal sign, right? Equals the box above it times, if it's every minute, it's going to be times 60, right? I barely have any. I went from divvying up my interest every hour of the day for a year to every minute of the year, right? And that's how many times I compounded, but I only went up a little bit. Right, well, what about every second? So every second means I'm going to take the value above that. I'm going to do times 60 again. And sure, it went up a smidge, but like in money, it doesn't really go up anything. So what's going on here? What Leonard Euler, E-U-L-E-R, what Leonard Euler wanted to figure out is like, is there a growth factor? Similar to pi, is there some constant number? But in this case, we see it's also like pi, an irrational number, that we can use as our growth factor whenever we're representing a situation of continuous growth, but not that happens every day, every month, every whatever, but just it's always growing, right? If you're talking about bacteria in a petri dish, if you're talking about the hair on your head, we're talking about things that just continuously grow. So whenever you see the word continuous, we're going to use this button on our calculator, E, Euler's number, lowercase e, and e to the first power, or e on its own, is 2.718 essentially. So you should know that value, and that is used every time we talk about continuously compounding interest. And as you see over here, continuously compounding, we have A, amount at the end, equals P, principal amount, times E, Euler's number as my base, raised to the RT, and that is what we will use from there. So let's just quickly go into this example. So I'm going to set this one up. Hopefully I don't go too long. Where am I now? Under 9 minutes. So let's try to get this done. All right, so here we're trying to choose between 2 different accounts. So the first account I'm looking at, we have $8,000. Always reread it carefully, because sometimes people think like both accounts are comparing the same like interest rate or something like that. And it's just like a different type of account. And really, there's more differences than just that. So pay attention, right? You decided to invest $8,000 for 6 years, and you have a choice between 2 accounts. So it looks like those 2 pieces of information will remain steady for both, okay? So those 2 pieces will remain steady for both. The first pays 7% per year compounded monthly. Before we even continue reading, let's just go for it. A equals principal $8,000 times 1 plus R 0.07 over N, monthly is 12, raised to the NT, which is 12 times 6. All right, there we go. That's the first one. The second pays, and if you look, it's a different interest rate, 6.85% per year compounded continuously. So A equals PE to the RT. P is still 8,000. E is just E raised to the R, 0.0685. E to the R, T, and T is time, still 6 years. So there we go. So really, I'm better going to label it in the next part, A of 6 equals, so this is account 1. So I kind of color coded. First account right there, and second account is right there, right? And then this will be A of 6 right here. All right. So let's go ahead to our calculator and check this out. So 0.07, 12, 6 years, $8,000. Okay. So if I hit clear, the way I like to type these in my calculator is as follows. I always start with 0.07 and I divide that 1 by, in this case, 12. I got that number, leaving it on my screen. Adding it to 1 because that is still inside the parenthesis. I have that. Again, I'm not going to write it down and then round it. I'm going to leave it as is. Now I'm going to raise this. So in this calculator, I use the X to the Y button. And what am I raising it to? I'm going to use parentheses. So NT means 12 times 6. In parentheses, close the parentheses. If you raise it to the 12 and then multiply the whole thing by 6, you're going to mess up your answer. So I have that, and then that number gets multiplied by the 8,000 out front, and we get 12,160 and 84 cents. 12,160 and 84 cents. 12,000, I already forgot, 160 and 84 cents. So there we go. Now the other one will be, okay, when it comes to the E button, if I do the E button, if you see that E to the X button right now, I'm about to press it, I'm going to get 1 on the screen. Well, actually, this calculator actually shows me I'm doing E to the 0. So whatever number's on the screen, there's a lot of calculators that when you press the button, it'll take the square root of whatever's on the screen. It'll do E raised to whatever's on the screen. So if I do E to the 0, I'm going to get 1. So that means I want to figure out what the exponent is. So 0.0685 times 6 is my exponent. So I'm going to do E raised to that value equals, and then times P is times 8,000 again. And we get $12,066.60. So $12,066.60. So which one is the better investment? The better investment is, in this case, the first account. Is it a lot better? I mean, I wouldn't say it's a lot better, but it's better, right? So there you have it. That's the end of this example. I was able to kind of crush that all into 13 minutes. Hopefully you got something out of it. So if you love it, you could thumbs it up. If not, go ahead, thumbs it down. Questions, comments, concerns, requests, and feedback in the comment section. Check the playlists or description box for more. And bye for now. Adios.